All right, so in the next sections, Dewey is going to talk about some differences between the Greek conception of nature and the modern scientific conception of nature. We're going to deal with kind of one, it's got different parts to the conception at first, and then the next video we'll look at another difference. But let's get started with this first fundamental difference. So Dewey says, I come now to the fundamental difference between the Greek conception of nature as it is expressed in Aristotelian cosmology, ontology, and logic, and the modern conception as that has been determined in the scientific revolution. So, again, differences between Greek idea of nature and the modern scientific idea of nature. The most evident point of difference concerns the entirely different position given to the qualitative and the quantitative in their relations to one another. So remember, modern science emphasizes the quantitative, so amounts of stuff, whereas earlier science, and of course common sense still today, emphasizes the qualities of stuff, whether they are satisfying or unsatisfying, what do they do, how are they useful, not useful, and stuff like that. So common sense and pre-modern science were concerned with qualities more than quantities. And modern science is now more emphasizes quantities. All right, so it is not merely that classic cosmology and science were constituted in terms of qualities, beginning with the four qualitative elements, earth, air, fire, and water, which are themselves constituted by combinations of the contraries wet, dry, cold, hot, heavy, light. So it's not just, or not merely, that the older versions of cosmology and science were based on qualities, but that all quantitative determinations were relegated to the state of accidents, so that apprehension of them had no scientific standing. So it's not just that qualities were more important, it's also that quantities were less important. They were what was accidental. They had no scientific standing. Accident, quote-unquote accident, is, of course, here a technical term. It does not imply that there is no cause for things existing in one amount rather than another, but that the cause is so external to the thing in question as not to be a ground or reason in knowledge. So as I think Dewey is going to emphasize in just a moment, the accidental is what is not essential, right? So the quantity of a thing was not thought to be essential to the nature of that thing. It was accidental whether you had, to the nature of a thing, whether you had 5 of it or 1 of it or 100 of it. And you can think of the kind of typical things you would find in ordinary life. Science during the Greeks' time was not really concerned with the microscopic so much, and they had a certain limited idea of really big events or objects, what we now might call hyperobjects. I was just reading something about hyperobjects, so I think the Greeks probably had a limited conception of what we might nowadays call hyperobjects. They probably had some, but nowhere near the kind of variety of large-scale processes and objects and events that we are now aware of. But those kind of ordinary kinds of objects, it doesn't seem like, whether you have 100 apples or 1 apple, it doesn't seem like it makes a difference to what an apple is. So going on, the meaning of accident is determined by contrast with essence. That was kind of the point I was just making, sort of foreshadowing where Dewey is going. That which is accidental is no part of essence and does not follow in any way from essence, since the latter is the proper subject of knowledge, and since quantity, such as magnitude, amount, is wholly irrelevant to essence, in the Greek view, consideration of it is outside the scope of knowledge in any grade except that of sense. So we can sense that there is more or less of something, but it doesn't make a difference to our knowledge of that thing in terms of rational knowledge. As matter of sense, it tends, moreover, to prevent ascent above sense to understanding. So it doesn't help us get above sense to a greater understanding of the thing, to know amounts or magnitudes of the things that we're trying to understand. There was, therefore, on the basis of the Aristotelian theory of nature and knowledge, no point or purpose in making measurements, except for lower practical ends. So measurement was, of course, a practical thing, but it didn't really have any scientific usefulness. Quantity, the thing to be measured, fell wholly within the scope of more and less, fewer and greater, larger and smaller, or the changing. And as we've seen previously, change is what is accidental, right? It's the inessential. Measuring was useful to the artisan in dealing with physical things, but that very fact indicated the gulf which separated quantity and measuring from science and rationality. And remember, also there's a pretty big split beginning with the Greeks between kind of pure thought, science, philosophy, and kind of the lower practical fields, the practical arts, kind of the applied, what we might nowadays call the applied sciences. There was kind of a big gulf opening up between those things. That was partly a social thing, part of the nature of Greek society. Observe by contrast, the place occupied by measuring in modern knowledge. Right? Measuring is one of the key tools, maybe the key tool in modern science. Everything must be measurable. Right? We compare measurements between things, and that's how we ground our knowledge of things, is through measurement. And then final sentence here. Is it then credible that the logic of Greek knowledge has relevance to the logic of modern knowledge, since they're based on such different understandings of what is important in terms of figuring out what's going on in the world? Does it make sense to derive logic from Greek logic? Of course, Dewey is going to answer no. This is why this chapter is about the needed reform of logic, of course. Going on, so he's going to talk about another kind of related difference. So there's one other difference, I think separate from, well, it's, related, as he says, but we can think of it somewhat in distinction from the quantity-quality difference that we saw before, or maybe a special way of thinking about that difference. So Dewey writes, another closely connected difference is found in the fact that because of the qualitative nature of the subject matter of knowledge in the Greek conception of nature, heterogeneity was postulated as a matter of course, where modern science postulates homogeneity, endeavoring to substitute homogeneity for qualitative diversity. So because the Greeks were concerned with qualities, you end up getting this very heterogeneous view of nature, which is rather different from science, where we're always trying to reduce things down to smaller measurable forms. And when you start getting down to, this is again kind of foreshadowing what Dewey is going to talk about, or hint at least, when you start getting down to things like atoms, these are not really qualitative things as we understand them now. They're measurable. We can measure them in some way. They're defined in a way by their measurement, but one electron does not seem to be different than another electron, right? Don't seem to be qualitative differences among electrons. Maybe there are, but so far things seem to work well enough as long as we measure them, make quantitative differences among, how many electrons are here, what is the position of the electron, how is it spinning, and so forth. You have what can be defined as quantitative differences. But the quality, we may as well assume it's the same, right? Homogeneous. That all the electrons are kind of the same, except for how they are moving, how many of them, except for the quantitative differences. So you get a much more homogeneous view of nature in modern science. And we'll explore a little bit of that difference in this paragraph. The difference is illustrated in the contrast between the present theory of chemical elements and the four qualitative elements, 5 including the ethereal substance of the fixed stars. So fire and water are obviously qualitatively distinct to each other for human beings, right? They have distinct qualities. It doesn't really matter how much fire you have, how much water. They're just different things. They seem to be different sort of things to us. But when you start going down again to the atomic and subatomic level, then it's more difficult to say if there are qualitative differences. There's quantitative differences, right? Hot things are moving faster than cold things. Wet things are, liquids are structured in a little bit different way than gases. But these are things that are notably quantitatively determined more than qualitatively determined. When you get to the human level, the physical human level, qualitative differences become really important. When we get down to other levels that are important for really figuring out the behavior of things and what we consider to be the kind of scientific nature of things, then quantities become much more important. So you look at a periodic table, it's all about the quantities of the parts of the different elements. All right, but the most striking instance, however, is found in the conception of qualitatively different kinds of movement that controlled science until, say, the 16th century. So I've been talking about, objects or substances. Dewey's going to give the example of movement, which is a really interesting example as well, because it's probably something we in the modern world don't think about as much. We don't think about things in quite this way. So instead of motion as measured change of position in space occupying a measured amount of time, so this is kind of the modern scientific view, where motion measured as position in space over time, right, which is a very kind of abstract, homogeneous way of thinking about motion. But for the Greeks, circular movement, to and fro and up and down movements were conceived to be qualitatively exclusive of one another. So they were different things. Circular motion was a qualitatively different kind of thing than moving forward and back or up and down. They marked substances of different natures occupying places of different values in the hierarchy of species. Different ends or completions respectively controlled them. So different things moved in different ways. So those different ways were qualitatively different, and it was important that they were that the different kinds of movement were qualitatively different, not just a measurable thing, not just something you could measure like faster or slower, but it was a different kind of thing. Earth comes down or falls by its nature and by the nature of its proper place. Fire and light move up for a similar reason. Levity is as much an inherent quality as is gravity, and so with the essences of other modes of movement. So different kinds of objects had their, the ways they moved was an essential part of them. It wasn't a kind of quantitative addition, but an essential part of that thing was having a particular kind of motion. Stones have the quality of going down towards the middle of the earth. Fire has the quality of moving up toward the sky. All right, let me see where I am for today. Just, I think another paragraph or so, or actually a few more paragraphs. Because of the teleological principle that knowable change tends toward a limiting fixed end. Sorry, there was going to try to read the footnotes today, and trying to remember where they were. Oh, I already missed one, but that one was not too important. Just a little bit about measurement. Let's not worry too much about that. I'll try to get footnote number 5. I think that's a little bit more important. All right, start this paragraph over. Because of the teleological principle that knowable change tends toward a limiting fixed end, all motion was thought to tend naturally to come to a state of rest. This notion controlled science till, say, the time of Galileo. So think about how hard it would be to come up with the idea of things not coming to a state of rest, right? Most objects that we have experience of, they don't keep moving, right? They move and they stop. You push something, it stops when you stop pushing it. You throw something, it eventually falls back down and stops moving. This notion controlled science until around the time of Galileo. Note, in contrast, the place of homogeneous motion in modern science, a homogeneity differentiated by angular direction, momentum, and velocity, which are all capable of measurement, so measurable motion. So when you get down to the measurement, it becomes a homogeneous kind of thing. Anything can move. The movement of anything can be measured in all these different ways. The difference cannot be dismissed as simply a difference in the details of subject matter and without relevance for logic. Self-returning qualitative movement is at the heart of the classical conception of reason and rational subjects. Its qualitative difference from other kinds of movement is the criterion by which forms of knowledge are graded. In addition, the difference of scientific concern with measurement and magnitude is involved. So I think he means here basically that in the classic conception, the Greek conception, different objects have their different natural ways of moving. They tend to go to their proper place, right? Certain objects tend to go toward the center of the earth. Other kinds of substances tend to rise into the air. That's part of their essential nature, qualitatively different, which is different than the quantitative measuring that we do today, where we're just looking at the direction of things, the angle, the direction of movement, the angle of movement, the speed of movement or velocity of movement, and so on, which are all measurable factors, applied similarly to any kind of object, really. And we're not looking at kind of the natural tendency of an object to move one way or the other, end up in one place or another. All right, and going on, so a third difference, let me turn the page here. All right, and then a third difference, which is connected again to this quality-quantity difference. A third closely connected difference is found in the fact that modern science is concerned with institution of relations, while classic logic is based on a theory of nature which treated all relations, save that of inclusion and exclusion of species, which was not conceived to be a relation, as accidental, in the same sense in which quantity is accidental. So, relations. This is going to be a big topic, a big theme, a big concept in modern science. But as with accident, relations between things were seen to be not essential to what the thing is. And we still tend to think of things in this way today. Objects are just what they are, despite how they are related. On my desk, I have various objects, pens, cups, smartphone, paper. These things, it seems to us from a naive perspective, it seems to us that these things are just what they are, and the particular relations among them are accidental, right? I could move them around and they would still be what they are. And I won't go into all the complexities of this, maybe why this is not maybe the ultimate truth here, but this is kind of the way, if you were to try to think about why the Greeks thought this way, I mean, it makes sense, right? It makes sense if you look at the objects around you. The particular place does in some way seem to be inessential to the object. And of course, now we know that's not entirely true. Again, I don't want to get into all the details of that just yet. Except for inclusion and exclusion, because that is of the essence of something, that it is this kind of species and not that kind of a species. All right. To be related meant in the Aristotelian scheme to be dependent on something outside of itself. But this dependence was not generalized and regarded as forming the very structure of a scientific object. So again, let me look at that sentence again. To be related meant, so if something is related to something else, it's dependent on that other thing. And it was not, scientific objects were not understood to be essentially related in that way. On the contrary, it was put in sharp opposition to the independence, self-sufficiency, and self-activity of substances, that are the only objects of scientific and demonstrative knowledge. Now, to be here and then to be somewhere else was dismissed once for all as the sign of inferior matter, while in modern science, such a change sets the problems of scientific inquiry. So whether something appears, when, or the conditions under which something appears were not understood to be constitutive of that thing in the older way of thinking, whereas in modern science we know why. We want to know why does this thing appear when it does. Why is it here rather than there? What are the conditions under which it appears? Maybe take, for example, something like an eclipse. We want to know what are the conditions. It's not just a particular thing, but it appears under certain conditions. It happens. It's an experience that can happen under only certain conditions, and we want to explain what are all those conditions. And it's a relation, right? It can only be understood as a relation among various kinds of things, among various celestial bodies and observers. So there's much more, observer dependence for one thing in modern science. I mean, some people like to think that it's very objective and independent of us looking at things, but the observer's relation to the thing is part of what makes it that thing, at least for us. There are things, anyway, let's not go too far down that road just at this moment. So last paragraph for this section here. Taking both measurement and relations into account, it is not too much to say that what Greek science and logic rejected are now the head cornerstone of science, although not yet of their theory of logical forms. So logic is still kind of mixed, partly based on Greek logic that was developed to deal with a very different kind of inquiry. And that type of inquiry tended to push aside these aspects of things that are central to modern science. The head cornerstone of science, as Dewey says. Measurement and relations. Modern science is all about measurement and relations. Contemporary logic has moved far enough to criticize the old logic form. To recognition, for example, of propositions of the subject or substance predicate form, it has added relational propositions. So we have added new kinds of propositions to modern logic, as opposed to just the subject-predicate or substance-predicate propositions. This is a marked advance. But up to a certain point, the addition has increased confusion in logical theory as a whole, since no consistency of theory can be attained as long as the theory of antecedent subjects, given ready-made to predication, is retained. So that's a key point in this chapter. So you can't just keep adding new forms into the old logic. You actually have to fully change that logic because the previous logic is based on a theory of antecedent subjects given ready-made to predication. And that's kind of the common sense view, that we have these ready-made objects that exist kind of on their own, aside from us. They have their own independent existence, independent from each other, independent from us. Whereas the modern scientific view is going to look at the relations among those things and define things through relations and measurements of relations. And footnote 5, I was going to try to remember to read the footnotes because I usually forget that. Number 5 is a little important. At least I'll read it anyway because I'm thinking about it. So footnote number 5, I don't have it on the screen. It's in a different file. But it says some specific instances of this confusion will be pointed out later. So Dewey is going to give some examples of this later on. The underlying logical point at issue is not the special Aristotelian conception of substance, but the idea that any kind of subject, such as this, or a sense datum, can be given ready-made to predication, to making statements about what it is. So any kind of sense datum is not just a ready-made thing out there existing apart from us, apart from other things. Sense datum, right, could be a color, a feeling, something you hear. These are not fully independent existences that are pre-given for us to just pick up and define, but they're relational things. Okay, so I will stop here and then we'll continue with some other differences in the next video. And then, yeah, so one more section of differences that I want to get through, and then Dewey kind of starts wrapping up this chapter. All right, that's all for now.